Welcome to the selection committee members of the IAPT Dinabandhu Sahu Memorial Award 2022. Myself, Dr. Shiva Udachan, Department of Physics, working at Government First Aid College, Shahpur, ST Kargil, Karnataka. My date of birth is 20th December 1984. Since for the last 8 years, I have been working for undergraduate students. So far, I have published 12 publications, presented papers orally as well as poster in the 24 international conferences. In the national conferences, it is 21. I have participated in more than 30 refresher course or symposiums and so on. I'm a life member of 4 academic bodies. That is, first one IAPT, second one Indian Vacuum Society in Mumbai, third one is the Karnataka Rajya Vijnana Parishad, and fourth one is the Karnataka Physics Association. Till now, I have filed 2 patents. Title of my today's lecture is Energy Sources. You can have a glance at this picture. What is a natural resource? What natural resources do you know? Natural resources are those substances required by humans for different needs. It is present in the nature in the form of crops, water, coal, forest, and so on. You can have a glance at this picture. What is an energy resource? What energy resources do you know? Energy resources such as oil, gas, coal, wood, wind, sunlight, and waves can be used to produce energy. These are energy resources. What is a non-renewable energy resource? What is a renewable energy resource? Non-renewable energy sources are things like coal, natural gas, and oil. They cannot be easily replaced because they have taken millions of years to form. We are using them faster than they are being made. This means that one day they will run out. Renewable energy resources like wind power, wave power, solar power, and biofuel can be easily replaced and will not run out. So these are the forms of the natural gas that is non-renewable. Examples are coal, oil, petroleum, nuclear power. Earth's crude oil and natural gas is formed from marine plants and animals that died millions of years ago. Dead microscopic animals and plants sink to the bottom of the ocean and become buried with other sediments, that is sand and mud. These are the layers of the sediment. These are rich in organic rich sediments, phytoplankton and zooplankton. This is a picture of the organic rich sediments. Over millions of years, these sediments get buried deeper and deeper. Temperature and pressure rises, and the microorganisms in the sediment are turned into gas and oil. Okay. Now, oil and gas move upwards through tiny pores in the rock. Oil and gas gets trapped under impermeable layers of rock and can then be taken out using long, powerful drills. Crude oil is turned into a jet engine oil, petrol, and diesel, which are used as a fuel in planes and cars. When oil and gas are burned, they release carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas and contributes to global warming. Okay, this is the picture of the tropical swamp. You can see here. This is the older rock layers formation. Carboniferous period 360 to 299 million years ago. Okay, this is Jurassic period. That is 201 to 145 million years ago. It has taken place. Dead plants turn into meat. This is the modern day. That speed turns into coal. Here you can see the heat formation and the pressure formation also. Coal is cheap and there is lots of it. When coal is burnt, it releases carbon dioxide, sulfur dioxide, and nitrogen dioxide into the atmosphere, contributing to global warming and acid rain. Uranium and plutonium are nuclear fuels. Nuclear fuels do not produce harmful greenhouse gases. Nuclear power is very efficient. Nuclear power produces radioactive waste, which is dangerous and has to seal in containers and buried for thousands of years. These are the forms of the renewable energy sources, that is geothermal, wind, hydroelectric, biofuel, and solar. First, let us discuss about the wind energy. Wind turbines operate on a simple principle. The energy in the wind turns two or three propeller-like blades around a rotor. The rotor is connected to the main shaft, which spins a generator to create electricity. You can have a glance at this wind turbine rotor. These are the blades, rotor, pitch system, generator, controller, yardroy, tower. So the function of the blade is to lift and rotate when hit by wind, causing the rotor to spin. Rotor, it is a combination of the blades and the hub. This system turns the blades out of the wind to control rotor speed, also stops the rotor from spinning in conditions where wind is blowing too slow or too fast. Generator produces 60 cycle AC electricity within the turbine. Controller, it starts and stops the turbine from working depending on the conditions. Yaw draw controls upwind turbines to orient them should wind direction change. Tower, the base of the turbine built to support the rest of the structure. This is the pitch system. You can have a glance at this. Turns blades out of the wind to control rotor speed. Also stops the rotor from spinning in conditions where wind is blowing too slow or too fast. Large windmills are called wind turbines. When the wind blows, the blades move and this spins a turbine, which is connected to a generator, which generates electricity. Wind farms are made up of lots of wind turbines. This allows lots of electricity to be generated. Wind farms are built in windy areas. No wind means no electricity. Advantages of wind energy: clean and renewable source of power, cost effective, rapid growth of industry, large potential. The disadvantages of wind energy are wind reliability, threat to wildlife, noise and visual pollution. So now let us discuss about the solar energy. Solar energy is from sunlight. Solar energy can be used to generate heat or electricity. Solar panels filled with water are used to produce heat. Photovoltaic cells are used to turn sunlight into electricity. Solar panels can be put on building roofs. Solar panels are expensive and you need a lot of them. We use solar thermal energy systems to heat water for use in homes, buildings, or swimming pools, heat the inside of homes, greenhouses, and other buildings, heat fluids to high temperature in solar thermal power plants. Solar photovoltaic devices or solar cells change sunlight directly into electricity. The two benefits of using solar energy are systems do not produce air pollutants or carbon dioxide. Systems on buildings have minimal impact on the environment. The main limitations of solar energy are the amount of sunlight that arrives at the Earth's surface is not constant. The amount of sunlight varies depending on location, time of day, season of the year, and weather conditions. The amount of sunlight reaching a square foot of the Earth's surface is relatively small, so a large surface area is necessary to absorb or to collect a useful amount of energy. Tidal energy. You can have a glance at this picture, how the tidal energy is formed, its functioning, so on. Tidal steam generator makes use of the kinetic energy of moving water to power turbines in a similar way to wind turbines that use wind to power turbines. Tidal barrage. Tidal barrage makes use of the potential energy in the difference in height between high and low tides. Advantages of tidal energy are clean fuel source compared to fossil fuels, domestic source of energy. Disadvantages of tidal energy are tidal power can have effects on marine life. The turbines can accidentally kill swimming sea life with the rotating blades. Some fish may no longer utilize the area if threatened with a constant rotating or noise-making object. Installing a barrage may change the shoreline within the bay or estuary, affecting a large ecosystem that depends on tidal floods. Wave energy. Ocean waves contain tremendous energy potential. Wave power devices extract energy from the surface motion of ocean waves or from pressure fluctuations below the surface. You can see these pictures. Advantages of wave energy are they are renewable, environmentally friendly compared to fossil fuel energy, variety of designs to use, less energy dependence from foreign governments. Disadvantages can affect the marine environment, may disturb private or commercial shipping, dependent on wavelength for best operation, poor performance in rough weather, visual or noise issues. Geothermal energy. You can have a glance at this picture. Geo is equal to earth and thermal is nothing but heat. Geothermal energy comes from heat produced by the earth. So we can have a look at this picture. Geothermal energy is heat energy from the earth. Water can be pumped down into hot rock where it is heated. Geothermal energy can be used to produce heat or electricity. Iceland is very volcanic, so uses a lot of geothermal energy. Direct geothermal energy can be accessed in areas where hot springs or geothermal reservoirs are near the surface of the earth. Geothermal heat pumps utilizes a series of underground pipes, an electric compressor, and a heat exchanger to absorb and transfer heat. Geothermal power plants also harness the heat of the earth through hot water and steam. In these plants, heat is used to generate electricity. Advantages of geothermal energy are renewable energy, cleaner than burning fossil fuels. Disadvantages of geothermal energy are cost of drilling, researching proper areas requires a suitable location. Now, let us discuss about the biofuels. The two most common types of biofuels are ethanol and biodiesel. Ethanol is an alcohol. Ethanol is mostly used as a fuel additive to cut down a vehicle's carbon monoxide and other smog causing emissions. Biodiesel is made by combining alcohol, usually methanol, with vegetable oil, animal fat, or recycled cooking greases. It can be used as an additive to reduce vehicle emissions, typically 20%, or in its pure form as a renewable alternative fuel for diesel engines. Advantages: easy to source, renewable, reduces greenhouse gases, reduce dependence on foreign energy. Disadvantages of the biofuels are higher cost of production, lower supply than gasoline, monoculture, shortage of food, water use. Okay, this is the hydrothermal energy. Hydroelectric power is a way of harnessing energy from running water. You can have a glance at this picture. Hydroelectric dams trap water in reservoirs. When electricity is needed, water is released and flows downwards with gravity to spin a turbine, more reliable than solar and wind power. Hydraulic dams are very expensive and can harm wildlife. Biofuels are made from crops. We can have a glance at this picture. Ideally, biofuels should be carbon neutral, absorb carbon dioxide as they grow, and then give off carbon dioxide when they are burnt. However, fossil fuels are used in the production of biofuels, for example, in making fertilizers, so they are not carbon neutral. Crops for biofuels could be used to feed people instead. So, you can have a look at this uh, activity that is generating electricity. How much energy do I use? Have a look at some electrical appliances around the classroom or school. See if you can find their energy ratings. Okay, how much energy do I use? Okay, energy is divided by time in seconds, that is power. Okay, you can have a look at these electronic gadgets. Okay, so we are using 140 watt for the LCD and 2400 watt for the heat, boiling the water, 800 watt and 10 watt for the bulb, and so on, and 4 watt for charging the mobiles. Okay, every day you can have a glance at these pictures. Every day products like food containers, smartphones, computers, and cars require a lot of energy. Recycling products saves energy. The amount of energy you save depends on the product, but it is always worth recycling. Energy saved is 94%. Energy saved will be 10 to 15%. Recycled element can be, it is of the form, you can see recycled glass jar. You can have a glance at this picture. Okay, you can do the homework. So these are the homework for the students. You can have it, you can take down. Okay, about my work. My work concentrates on the study of electrical and microstructural properties of some metallic thin films, namely chromium, tin, and silver. Here I am highlighting some work carried out by me. It is as follows. Substrate material plays a vital role in defining the physical characteristics of vacuum deposited films and happens to be one of the important deposition parameters similar to that of film thickness. By the proper choice of deposition parameter or selected combination of deposition parameters, it is possible to grow films of specific characteristics for specific application. The use of soda glass substrate has been the most common material for film deposition, and other substrates like quartz, mica, Teflon are growing in importance. An attempt is made to study their effect on the electrical resistivity of thin film films in the thickness range 40 to 160 nanometer. We have made use of Fox size effect and Mayada's Shakes theories for analyzing the electrical resistivity data for tin films grown on glass and quartz substrates. The infinitely thick film resistivity, conduction electron free path, and specularity parameter are found to depend upon the nature of substrate and the binding force between substrates and evaporated tin atoms. In order to confirm the material used under present investigation in tin, the electron dispersive spectroscopy, that is EDS analysis of film, have been undertaken using SEM, that is scanning electron microscope. Tin has a low resistivity, low melting point, high temperature coefficient of resistance, that is TCR, and negative thermoelectric power, that is TP, in the bulk form. It develops a milky white surface because of its unspecular reflectivity. Therefore, tin is rendered unsuitable for mirror coatings. However, it is used as one of the components in solder material. In view of the above-mentioned interesting properties of tin in the bulk form, a systematic study of the influence of substrates on the electrical properties of thin tin films have been undertaken herewith, as the electrical properties of thin films are known to sensibly depend on the surface morphology of substrates and the sticking coefficient. We have first estimated the conduction electrochemical path in bulk tin, that is sigma is equal to n square tau upon m, where n denotes the concentration of electrons per meter cube, E is the electronic charge, m is the effective mass of the electron, and tau is the relaxation time, where tau is equal to L upon Vf. Here, L stands for the electronegative path, and Vf is the velocity of electrons at the Fermi surface. From the above equation, we obtain the electronegative path in bulk tin is 5.395 nanometer. But however, we have selected the thickness range that is from 40 to 160 nanometer, as there was no electrical continuity of tin films below the thicknesses 40 nanometer. From the above equation, we obtained the electronegative path in bulk tin as 5.35 nanometer. Now let us discuss about the experimental section. The vacuum coating unit used in the present investigation is the thin-high vacuum coating unit model 12A4D to grow thin films of tin. Initially, the substrates were cleaned in chromic acid and then by ultrasonically. That is, the substrates were suspended in the ultrasonic wave generated tank, which contains detergent water and is agitated with ultrasonic frequency. Thus, clean substrates were again cleaned in distilled water, acetone, and dried. These are mounted on the substrate holder plate and kept in the vacuum chamber. Before deposition of the tin films, once again, all the substrates were cleaned by ionic bombardment technique in the vacuum chamber. Prior to the deposition of the film, the system was thoroughly degassed. Tin of purity 99.99% was evaporated from a molybdenum board by resistive heating, thermal evaporation in vacuum method at the rate of 0.2 nanometer per second under a vacuum of 2 into 10 raised to minus 6 torr onto cleaned glass and quartz substrates held at room temperature, that is 23 degrees centigrade. The distance between the substrates and the evaporation source was around 0.20 meter. The film thickness was controlled and measured by means of an inbuilt quartz crystal digital thickness monitor model, that is DTM 101, which could resolve thicknesses up to 0.1%. The experimental methods preparation are given in other communication. Electrical resistivity measurements have been performed in situ with the standard four-probe technique. We have used a constant current source to maintain a current of 0.01 milliampere through the film. In order to study the surface morphology of the films, the atomic force microscope AFM images, and for microstructural analysis, scanning electron microscope, some images have also been undertaken. Energy dispersive spectroscopy EDS study allows one to identify what those particular elements are and their relative proportions, that is, atomic percentage, for example. Achievements. I have presented two research papers orally. One of them has been edged as an excellent paper by the guest editors and referees reports of 20th Jubilee International School on condensed matter physics and applications of advanced and multifunctional materials held at Varna organized by Georgi Nadjakov Institute of Solid State Physics, Bulgarian Academy of Sciences, Bulgaria, from September 3rd to 7th September 2018. Secondly, I have been awarded outstanding work for oral presentation entitled Base Pressure Effect on Electrical Properties of Chromium Nanofilms at International Advanced Study Conference Condensed Matter and Low Temperature Physics 2021 during June 6th to 12, 2021 at Kharkiv, Ukraine. Thirdly, I have been invited to review for the Journal of Ingeniería y Universidad Engineering for Development Journal, Colombia, South America. And fourth one is I have five patents, that is two. Title of the patents: a method for aiding resistivity and energy gap measurement of semiconductors, application number 201941049633, date of filing 3rd December 2019, Indian Patent Office, Chennai. Second title of the patent is a method for accurately calculating the thermal conductivity of a bad conductors, the least disk method. Application that has been filed. Title of the application number is 202041006689. Date of filing is the February 17, 2020, Indian Patent Office, Chennai. And recently, I have been awarded second prize at the state level, IAPT. That is, title of my experiment is low cost experiment for foolproof technique at the regional competition of innovative experiments in physics held on July 10, 2022 at Maharani Lakshmi Amani College, Bengaluru, Karnataka. Thank you to all of you. Stop.